Hi, good afternoon. Glad to see you all here and remaining. So I got the challenge to keep you entertained for the last few minutes of the conference. So that is the title of my presentation. It's a mouthful. So I'll basically try to describe two issues. One is the very proficiency exercise that we conducted in Latin America. And the other one, I'll try to link these with different tools, different approaches, in the road to elimination. As Cameron said, I'm working at the School of Veterinary Medicine in the University of Surrey, but I'm a very novel academic, only 5 months into this university. Basically, my background, I'm an epidemiologist, and I used to work at the Pan American Health Organization based in Brazil, and I used to visit the whole region. So that's why, obviously, I am sort of informed to talk about the following. So I think it's customary that we all present the importance of rabies. I hope that the fact that this presentation is the last doesn't mean that rabies is at the very bottom of the. No, right? Yeah. So rabies. My colleagues have been presenting the burden of the diseases during the last 2 days, talking about the hundreds of thousands or millions of people affected and the number of deaths. In rabies, it's much easier. The number of cases equal the number of deaths. It's 100% mortality, case fatality rate. There's only a handful of cases that have been saved, most of them with some non-canine variant virus. So. Latest estimates by Katie Hampson and colleagues, I think it was back in 2016, about 60,000 people dying every year of rabies. That's a horrible death. And this is the year 2017 map of rabies distribution. Nice colors. You can see in blue are the countries endemic, mostly obviously in Africa and Asia. As I said, I came from the American region. And the American region, we got a more heterogeneous, if you want, display of colors. So we got some countries that are really lagging behind with endemic cases, canine cases. By the way, I'm talking about canine rabies, dog-mediated rabies. There are many different types of rabies, and particularly in South America, we also have a big, important problem about bat rabies, vampire bat rabies and others. But here I'm talking about canine rabies. So in blue, in Latin America, dark blue, you can see Guatemala and you can see Bolivia still having cases of canine rabies and human cases transmitted by dogs. We got some pale blue somewhere in Central America as well. Sorry, I forgot to mention, the dark blue is very small, you probably don't see it, is Haiti. Haiti is our biggest problem in the region. Haiti is the only country in South America at the very lower bound of income. But we also have some countries that they have canine rabies in the dog population, but they don't suffer any human cases because they are pretty good at delivering post-exposure prophylaxis in the healthcare system. Cuba springs to mind. And then you have in South America all these beautiful colors. Green means no cases. So we have Uruguay and Chile, free from canine cases and human cases. The last case in Chile was in 2013. In Valparaiso, beautiful place. But then in Brazil, you have endemic cases in dogs in some areas, particularly in the northeast and the southwest, Peru, unfortunately, and occasionally some human cases. So that is the situation. But as you can see, the burden is mostly in Africa and Asia. And there is a goal. WHO likes to put goals and elimination goals for everything. We aim to eliminate canine rabies in the world by 2030. Needless to, we actually had 4 elimination goals in South America since 1983, when we launched a elimination program or control program 33 years ago. Throughout time, obviously, became an elimination program. 4 times we missed it. So there are a lot of lessons to learn in the elimination race. And this is just basically to describe the situation of rabies in the Americas. Again, canine rabies mostly. So you can see it's a success story. Yep. This is it. So here on the left, you can see that's the decline trend of the number of human cases by rabies human cases by dogs from about 300, 250 in 1983 to basically none last year. And a similar trend here at the bottom of the slide, obviously highly correlated, the number of dog cases from about 15,000 or 12,000 33 years ago to very few in the last year. So you would expect that, with this reduction in the numbers, obviously ministers of health, and they no longer allocate a lot of priority or on this rabies program. However, back in 2015, early 2015, we ran a survey to 53 ministers of health and agriculture across the whole region. And this table here at the top actually shows the result. Voila, rabies still remains the most important zoonotic diseases for all these 53, at least for 30 ministers of health and agriculture in the region. So we had obviously a mandate from the countries when I was at PAHO to obviously keep all the pressure and all the advocacy on rabies. This is very much important for them. And then you have the other diseases like leptospirosis and others. And then within that very survey, we also asked them about of all these diseases that you put at the top of your list, and we had one list for endemic and one list for emerging. What sort of capacities you want the most? And as you can see here, for rabies, the response was very clear. We need more diagnostics. We are not pretty sure about diagnostics. I'm not a lab guy, as I said before. I'm an epidemiologist. I used to crunch numbers. So I was a bit disappointed that actually nobody replied that they needed or they felt as a critical thing to develop surveillance. And I'll be elaborating on that later on. So I was approached by Cameron and the Society to talk specifically about this paper that we published a couple of months ago or something like that. And this was actually, so this is an interlaboratory proficiency exercise. Believe it or not, the program started in 1983 in Latin America. The regional control and elimination of canine rabies. And only 33 years later, we managed to run the first interproficiency exercise for laboratory diagnosis, which is obviously very critical. I mean, we've been talking about running diagnostic tests within the lab and obviously achieving a high sensitivity and specificity. It is important to look beyond that and see how we are comparing between the different labs and between the different countries, especially if we start reporting the the epidemiological and disease surveillance results. So this was an exercise we conducted, I think, back in 2014, 2015. Logistically, it was a nightmare. We engaged with a number of partners. We engaged with the CDC in Atlanta, the Pox and Rabies Virus Division over there, who is a WHO collaborating center. And the colleagues over there, they produced this panel. I don't think you can say, but you can read it in the paper anyway. So we have a panel of 20 samples, 3 controls, and we have a huge variety of variants that we normally collect through the surveillance across the region, because the CDC basically has got a huge library of samples from many different countries in the region. I forgot to mention the purpose of the exercise was basically to check the performance of the labs in running the gold standard for rabies diagnosis, which is the DFA. We invited 30 labs across the Ministries of Health and Agriculture. Why we wanted to do that is because different from other regions, Africa and Asia, rabies programs in America are run mostly by ministries of health. Even canine vaccination is conducted by ministries of health, and a lot of rabies samples, even on domestic animals, are done at the ministries of health labs. But we also wanted to cover all the wildlife rabies samples that are conducted at veterinary laboratories, dependent on from the ministries of agriculture. And together with the panel, we also distributed an online questionnaire because we wanted to know what sort of practices could explain part of the variability that we expected from the labs. The results. Right, we got 23 labs out of 18 countries, so it's a pretty good return, 9 from the Ministers of Health and 14 from the Ministers of Agriculture. But unfortunately, some of the results were not as good as we expected. Having this program running for 33 years with very experienced and well-established structures and processes. So that is on the right on the left in your case, the plot of sensitivity and specificity for the 23 labs. Only 2 labs actually hit the 100% sensitivity and specificity, and which means that 91% of the labs actually has some discordancy with done some discordance sample with the CDC panel. And some of the results for some of the labs, obviously I cannot mention here, they were quite discouraging, like the ones here at the very bottom with sensitivities of just over 40%. They did much better, obviously, in terms of specificity, but sensitivity overall was about 70%, 75%. So we got some work to do, I'm afraid. We also obviously compared by sample, and what we identify is that the wildlife sources or the wildlife samples, they were the most challenging for these guys, especially those from mongoose, fox, and vampire bats. The concordance was between 30 and 45%. And we found a lot of heterogeneity in the SOP questionnaire, online questionnaire, and there could be, a possible reason for the results that we observe in here. The questionnaire was very extensive. The answers, again, are in the paper. You can read them. I'm not going to go through this table by any means, and I don't expect you to read it either. But we asked for a lot of practices at the lab level, and as I said, we found a lot of heterogeneity. We look at, the age of the microscope. We look at the number of samples they are processing every week. We look at whether they have quality program systems and things like that. And again, it really indicates that we got a lot of work to do in terms of standardizing these things in this region, which is miles ahead of the other two regions, which are Asia and Africa. So what are the next steps in terms of diagnosis, looking at the next elimination goal? So as I explained before, the American region had 4 elimination goals. The last one in 2015, we failed, but we are optimistic, and the next one will be 2022. So in terms of how we identify, the priorities we identify towards that elimination goal, we need to obviously to drill down into the details and look at the variants and the phylogenetic analysis of these things. Here on the right, I'm just showing a plot of a colleague of mine at the University of Surrey who ran all this phylogenetic analysis in Central Asia and other places, and it shows the importance of obviously knowing that knowledge. I have to say that for some countries in the region, in Central America, for example, they don't have the capacity to do this variant, which is the most basic stuff, to know whether it's a wildlife virus or it's a dog-mediated rabies, etc. And obviously, I have to say that WHO wasn't very quick in adapting new techniques. DFA remains the gold standard, and for some years, since 2013, the last expert commission report by WHO, there were some reservations about the DREAD technique, which obviously allows some decentralized surveillance, and at the time recommended further development. I'm happy to say that the last revision of all this evidence, which will be published in 2017, recognizes the importance of DREAD and many other tests that could help the decentralized diagnosis of rabies. Now I'd like to move from diagnostics into some field that I feel more comfortable, which is about epidemiology, a bit of epidemiology modeling and program related issues. And so in terms of the next steps towards elimination, not just for rabies, but for some of the diseases that I've been working in the region. I used to work on yellow fever, leishmaniasis, and echinococcosis as well. So here on the right, at least in my screen, this is another plot I recover. This is a spider plot I recover from that publication I just mentioned before. And it shows something that, again, is quite discouraging. So if you see rabies appears in dark blue, and obviously this is from the 53 ministers of health and agriculture, and they coincide with the previous plot that I showed you that, yes, they don't need much improvements in diagnosis. They're quite confident. And again, it coincides with the previous plot when they say, actually, I'm fairly confident about my surveillance, and I don't need any improvements in the surveillance, and certainly I know the surveillance sensitivity. Well, as I said, I spent a few years in the region. I visited most of the countries, and I can tell you that for rabies, that is not the case, which indicates that these guys really don't know much about processes, and they don't know much about what happens beyond the lab. We have to recognize that most disease program managers who actually responded to this survey They tend to be technicians that actually became managers at some point. And they are good at the very tangible things. When we talk about processes and optimization, they don't really know that much, which basically links with the speaker presentation, the keynote speaker presentation about the need for optimization, and start guessing and actually running decisions, that are data-driven, which is again an argument that we had a recent paper published about all these tribulations that the region in Latin America was suffering in the last few years in terms of establishing goals, elimination goals, and not reaching them, and the importance of optimizing resources. I mean, there is no room for mistakes or inefficiencies at the very last mile. Policymakers and budget holders, they have very little appetite for inefficiencies. So you have to change the practices. It's a completely different war. And this is something that we observed in the region. We had very successful disease program managers. They've been reducing the prevalence or the incidence of the disease for 30 years. Armies marching, mass dog vaccination, great success. This is a completely different game. We have to change from that approach to a sniper-like approach and recognize that cases will be much more difficult to find and more costly. There is also another issue that I want to bring out, which is the need to integrate evidence. Actually, the need to integrate everything, from data capture to data management to interpretation. And we need to move from the isolated approach and running different surveys with no strategic program or no strategy behind. At the bottom of this slide, you can see a table which shows basically the history of different surveillance or service approach by one province in Argentina. I won't say which one. I'm not criticizing, because actually these guys, at least they're going out and they do these things actively. But it shows the number of different surveys across many different years on different target populations with very little strategic thinking behind about how we integrate all this evidence in order to produce something that tell us what is the underlying occurrence of the problem. In fact, we are working towards that integration of this evidence at the moment. How we are working towards that integration? Well, something that I try to explain briefly here. Basically, I really like your presentation about zoonosis. In most of the region, in most of the countries I know, zoonosis risk is based on the number of human cases. If you're lucky, you not only use the counts, but you take into account the population, if you're lucky. Believe me, there are quite a few countries in the Latin American region for some diseases like leishmaniasis, which kills about 400 people a year only in Brazil. And I'm not saying anything that this is the problem in Brazil. They don't even consider the population at risk. So they classify, for example, municipalities based on case counts without taking into account the most basic thing, which is the population at risk. But they're also forgetting what happens in earlier stages of the risk pathway. For example, the occurrence of cases in animals. For leishmaniasis, for visceral leishmaniasis, we conducted that analysis. These are the two maps here at the top in red and pinky colors. These are municipalities in Brazil, some state in Brazil, and what we've done is basically integrate what happens in the dogs, domestic dogs, which is the biggest reservoir of visceral leishmaniasis in Brazil, together with the occurrence of human cases, and see if the occurrence of cases in dogs actually has got any predictive value at the municipality level, a quite fine granular level for the occurrence of human cases. And we see some progress. But in order to inform decision making, just showing where the risk is not enough. Ideally, you also want to tell them about what sort of vulnerabilities or capacities they have and what capacities they need to improve. And this is another part of the exercise we've done with leishmaniasis, visceral leishmaniasis in Brazil. We also plotted the vulnerabilities or the level of performance of different capacities related to detection of visceral leishmaniasis, both in dogs and humans. If you overlap the two, if you overlap a region or a municipality with high risk and low capacities, you got a problem. And that's probably the area where you want to invest most of your resources. The other thing that we are doing at the moment is also mapping uncertainties. Yeah, we talk about estimates, but we keep forgetting about the uncertainties. When you refer to sensitivity and specificities throughout these 2 days, I haven't seen any confident intervals whatsoever. None. They were all point estimates, but we all know that uncertainty has got many sources, And ideally, we want to tackle them because we need to be aware that having uncertainties actually affect the value of information for your subsequent decision making. There are a lot of examples here that I won't spend much time on about how we obviously use different sources of information to inform risk classification. This is done for Mexico and Brazil by colleagues in the University of Glasgow, Katie Hampson and others. There's been a nice study about risk incursion in Australia, recently published, with a lot of evidence in synthesis and evidence integration. We need to know more about what's happening in the population level. We keep guessing rather than using data-driven decisions about what is the dynamics of dog populations and wild reservoirs and interactions between the two of them. And then again, I'd like to go back to that point by Roy about optimization. There is a lot of need for implementation research about how we become more efficient in the way we implement programs in the ground, like how long do we need to vaccinate dogs for, or what types of dog. We keep saying that most of the dogs out there are stray because they are we haven't seen any owners behind. Actually, 95% of the dogs that you can see roaming free on the streets in many countries in South America, they have owners. What sort of dog surveillance, how long we apply dog surveillance, what is the sample size, on what animals, and things like that. We don't know these basic things for a disease that has been happening for a millennia or 2 millennia. So let me just finish saying something about this whole integration, optimization of evidence and many other processes throughout, not just for the control of neglected tropical diseases, but for any other diseases. Many of the things that we've been arguing and discussing at the different panels, they seem to me they have very little technical basis. A lot of the problems, in any problem, there are two sides. One is the technical, analytical problem, and the other one is the organizational. For many of these diseases, and we argue actually that for rabies in Latin America, the failure to eliminate rabies is not a technical problem, it's an organizational problem. In terms of all the different values, all the different convictions, the frameworks and cultures of the different stakeholders. I would also argue that it's not just needed, as I said before, to present the risk, to present the capacities. You have to go beyond that and actually support the decision at the policymaker. And we're trying to establish that with a number of analysis in terms of portfolio decision analysis. So once you tell the decision maker that he can apply different interventions, you have to assist him and you have to help him to decide which one will bring the most value for money. And that is the portfolio decision analysis we're applying on a number of diseases, specifically on cholera in Haiti. And my final point is, someone was talking about, there was a few conversations, a few points about community behaviors and things like that. At that meeting I was referring to in previous interventions a couple of months ago at the Imperial College, where we want to launch that modeling network by WHO, coordinated by WHO, focusing on pandemics and epidemics. There was many of the points that have been raised here that they also were discussed at that meeting. One of the limitations that the modelers found for all these diseases, epidemic and pandemic-prone diseases, was that we don't know how to measure properly and how we input or compute behavioral in communities, how we model this behavior in communities. Well, there are some steps forward in order to address that challenge, like, for example, measuring the loss aversion or the risk attitude of the population and the communities, and parameterizing these into a disease dynamic model and a case scenario model as well. And with that, I'll conclude, and I'll thank you for your time. Cheers.